Okay, 14 and 15. So with 14 and 15, these are kind of more basic trig equations. With 14, I would not try to factor this one because you have a 3 and that's kind of nasty to factor with. What I would do instead is take the square root of both sides. That is definitely your path of least resistance. You could change everything to sines and cosines, but you guys know how to deal with tangent, and we've gotten pretty good at that. Just remember, when you're taking the square root to solve an equation, you need to make sure you do the plus and minus of the other side. Whatever number you're taking the square root of, you have to take care of that plus and minus. When you have a squared, you should have two solutions. And so that should kind of, if you keep that in the back of your mind, that can help. So tangent of x equals positive and negative square root of 3. Remember our little memorization technique there was tangent is radical 3 at pi over 3. So here I know since I'm doing plus or minus, I need all the thirds. So I'm thinking pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those are all my thirds. Now to condense this situation a little bit, we can do and do our general formula for all solutions. We can group these that are pi apart. So pi over 3 and 4 pi over 3 are pi apart on your unit circle. And if you need to draw your diagram, I think that's helpful. So pi over 3 is here and 4 pi over 3 is here. So those two are pi apart. So if you write pi over 3 plus pi k, that takes care of both of those. 2 pi over 3 is in the second quadrant and 5 pi over 3 is in the fourth. They are pi apart. So if you write 2 pi over 3 plus pi k, you can take care of both of those. Don't overcomplicate that one. Take the square root of both sides, go on with life. All right. On 15, or this may have been your 14 if you took the other version D of this test, you need to think factor, not divide. It is very easy to divide on this problem and then lose a solution. So when you're thinking factoring, we're just doing GCF, cosine cubed minus cosine. Those two terms have a cosine in common, so I can factor out a cosine. And now I just set both of these little terms equal to 0. So cosine of x is 0. And I have cosine squared equals 1. It is easy to fall into the trap and lose a solution here, just like you might have on the tangent problem, because when we force the square root, we do need positive and negative 1 there. So make sure anytime you have a squared, whether it's in the middle of your problem or whether it's the whole problem altogether, that you're getting two solutions out. Here, our highest degree was 3, so we're looking for 3 solutions. And on the unit circle, of course, we might not only have 3 solutions, we might have 2 places for each of those. But we're looking for 3 things, really, that we're setting equal to 0. Okay, so cosine is 0. Sometimes the quadrantals are the hardest, so drawing a picture is helpful for me. Cosine is 0 at pi over 2 and at 3 pi over 2. So those are pi apart, so I can take care of that by pi over 2 plus pi k. Cosine is 1 at 0 and negative 1 at pi. So here you can write those separate or you can write them together. Since they're 2 different solutions, like for 1 and for negative 1, I would probably write them separate. So 0 plus 2 pi k and pi plus 2 pi k. Those are all very evenly spaced on your unit circle. All right, those are your first two trig equations.